NFPA 725, Chapter 725 governs the installation of standby power systems. Section 725.31 prohibits the installation of Class 2 wiring and equipment in the same raceway with Class 1 power cables. Class 1 equipment includes generators, transfer switches, and appliances. Class 2 equipment includes low-voltage systems such as control circuits and signaling devices. The NEC does not specifically address manufactured whips that contain both power and control wiring. However, there is an exemption in Section 725.31 that allows functionally associated equipment to share a raceway with power cables. In this case, a transformer inside a generator is functionally associated with the generator, which is considered Class 1 equipment. Therefore, the manufactured whip that contains both power and control wiring from the transformer would be exempt from the raceway separation requirement. The transformer should be rated for use in the specific generator application. The whip should be installed according to the manufacturer's instructions and the applicable NEC requirements. It is recommended to contact the local electrical inspector for approval before installing the whip. Based on the NEC exemption, the manufactured whip that contains both power and control wiring from the generator's Class 2 transformer would be allowed. However, it is important to follow all applicable installation requirements and obtain approval from the local electrical inspector. When considering electrical installations, understanding the National Electrical Code, or NEC, is paramount. The NEC provides guidelines for safe electrical practices. It's a comprehensive document. When dealing with generators and their associated wiring, several articles and sections of the NEC come into play. One common scenario involves the use of a pre-manufactured whip, a cable assembly that connects the generator to a transfer switch. This whip typically contains both power conductors for supplying electricity and control wiring for signaling and operation. The control wiring often originates from a Class 2 transformer located within the generator. This transformer steps down the voltage, typically from 230 volts to 12 volts, to power the control circuits. However, the NEC imposes certain restrictions on the mixing of different classes of wiring within the same raceway or enclosure. Specifically, Section 725.31 addresses the separation of Class 1, Class 2, and Class 3 circuits. Class 1 circuits are generally power-limited circuits operating at higher voltages and currents, while Class 2 and Class 3 circuits are low-voltage, low-energy circuits used for control and signaling. According to Section 725.31, Class 2 and Class 3 circuits are generally prohibited from being installed in the same raceway, cable, or enclosure as Class 1 circuits. This separation is intended to prevent the higher voltage of the Class 1 circuits from interfering with or damaging the low-voltage Class 2 or Class 3 circuits. The NEC defines Class 1 circuits as those operating at 120 volts or less and 30 volts amps or less, or those operating at 150 volts or less and 5 milliamps or less. Class 2 circuits are defined as those operating at 30 volts or less and 100 volts amps or less, while Class 3 circuits are defined as those operating at 30 volts or less and 0.5 volts amps or less. These classifications are based on the potential for electrical shock and fire hazards. Given this general prohibition, a question arises whether a manufactured whip containing both power and control wiring violates the NEC. In this case, the control wiring originating from the Class 2 transformer appears to be mixed with the power conductors in the same cable assembly. However, the NEC provides an exception to this rule in Section 725.31. For functionally associated equipment. This exception allows Class 2 or Class 3 circuits to be installed in the same raceway, cable, or enclosure as Class 1 circuits if the Class 2 or Class 3 circuits are functionally associated with the Class 1 equipment. The key to applying this exception lies in determining whether the Class 2 control wiring is indeed functionally associated with the generator. The term functionally associated is not explicitly defined in the NEC, but it generally refers to circuits that are essential for the operation or control of the associated equipment. In the case of a generator, the control wiring is typically used for functions such as starting, stopping, monitoring, and controlling the generator's operation. These functions are directly related to the generator's primary purpose of providing power. Therefore, it can be argued that the Class 2 control wiring is functionally associated with the generator. If the local electrical inspector agrees with this interpretation, the manufactured whip would be permitted under the exception in Section 725.31. However, it's important to note that the final decision rests with the local electrical inspector, who has the authority to interpret and enforce the NEC. To ensure compliance and avoid potential issues, it's always advisable to consult with a local electrical inspector before installing any electrical equipment or wiring. The inspector can provide guidance on the specific requirements and interpretations in your jurisdiction. In addition to the NEC requirements, it's also important to follow the manufacturer's instructions for installing the manufactured whip. The manufacturer's instructions may provide specific guidelines for routing, terminating, and supporting the cable assembly. Failure to follow these instructions could void the warranty or create safety hazards. Furthermore, it's essential to ensure that all electrical work is performed by qualified and licensed electricians who are familiar with the NEC and local electrical codes. Working with electricity can be dangerous, and improper installation can lead to electrical shock, fire, or equipment damage. In summary, while the NEC generally prohibits the mixing of Class 1 and Class 2 circuits in the same raceway or enclosure, an exception exists for functionally associated equipment. If the Class 2 control wiring in a manufactured generator whip is deemed functionally associated with the generator, the whip would be permitted under the NEC. However, it's crucial to consult with a local electrical inspector and follow the manufacturer's instructions to ensure compliance and safety. Let's delve a little deeper into the specifics of the NEC sections and the practical considerations involved in this situation. Section 725.3, titled Classifications, defines the characteristics of Class 1, Class 2, and Class 3 circuits. It outlines the voltage and current limitations for each class, as well as the types of applications for which they are suitable. Class 1 circuits, as mentioned earlier, are typically used for power and lighting applications, while Class 2 and Class 3 circuits are used for control, signaling, and communications. Section 725.26, titled Wiring Methods and Materials on Load Side, specifies the wiring methods and materials that are permitted for Class 2 and Class 3 circuits. It generally requires that these circuits be installed using listed or classified cables, raceways, or enclosures. The selection of appropriate wiring methods and materials is crucial for ensuring the safety and reliability of the installation. Section 725.31, titled Separation from Other Circuits, is the key section that addresses the mixing of different classes of circuits. As we've discussed, it generally prohibits the installation of Class 2 and Class 3 circuits in the same raceway, cable, or enclosure as Class 1 circuits. However, the exception for functionally associated equipment provides a degree of flexibility in certain situations. When applying the functionally associated equipment exception, it's important to consider the specific functions performed by the Class 2 control wiring. In the case of a generator, the control wiring may be used for the following purposes. Firstly, starting and stopping the generator. This involves sending signals to the generator's engine control module or starter motor to initiate or terminate operation. Secondly, monitoring generator status. The control wiring may transmit information about the generator's voltage, current, frequency, and other parameters to a remote monitoring system or display. Thirdly, controlling generator output. The control wiring may be used to adjust the generator's voltage, frequency, or power output to meet the demands of the connected load. Fourthly, communicating with a transfer switch. The control wiring may send signals to the transfer switch to initiate a transfer of power from the utility grid to the generator or vice versa. Fifthly, providing safety functions. The control wiring may be used to implement safety features such as overspeed protection, overcurrent protection, and low oil pressure shutdown. These functions are all directly related to the generator's operation and control, which strengthens the argument that the Class 2 control wiring is functionally associated with the generator. However, it's important to note that the local electrical inspector may have specific requirements or interpretations regarding the functionally associated equipment exception. For example, the inspector may require that the Class 2 control wiring be physically separated from the power conductors within the manufactured whip, even if they are contained within the same cable assembly. Alternatively, the inspector may require that the Class 2 control wiring be protected by a separate overcurrent device or grounding system. In addition to the NEC requirements, it's also important to consider the potential for electromagnetic interference, or ME, between the power conductors and the control wiring. EMI can occur when the electromagnetic fields generated by the power conductors induce unwanted currents or voltages in their control wiring. This can lead to malfunctions or errors in the control system. To mitigate the risk of EMI, it's advisable to use shielded cables or raceways for the control wiring. Shielded cables and raceways provide a barrier against electromagnetic radiation, preventing it from interfering with the control signals. Another consideration is the voltage drop in the control wiring. Voltage drop occurs when the voltage at the load end of a circuit is lower than the voltage at the source end, due to the resistance of the conductors. Excessive voltage drop can cause the control system to malfunction or operate improperly. To minimize voltage drop, it's important to use conductors of adequate size and to keep the length of the control wiring as short as possible. The NEC provides guidelines for calculating voltage drop in Chapter 9, Table 8. In addition to these technical considerations, it's also important to address the administrative aspects of the installation. This includes obtaining the necessary permits, scheduling inspections, and coordinating with the local utility company. Before starting any electrical work, it's essential to obtain the required permits from the local building department or electrical inspector. The permit application will typically require detailed information about the proposed installation, including drawings, specifications, and calculations. Once the permit is approved, the electrical work can proceed. During the installation, it's important to follow the NEC, the manufacturer's instructions, and any other applicable codes or standards. The work should be performed by qualified and licensed electricians who are familiar with these requirements. After the installation is complete, it's necessary to schedule an inspection with the local electrical inspector. The inspector will verify that the work has been performed in accordance with the NEC and other applicable codes. If the inspection is approved, the electrical system can be energized. Finally, it's important to coordinate with the local utility company to ensure that the generator is properly connected to the grid. The utility company may have specific requirements for the interconnection of generators, such as the installation of a transfer switch or protective relaying equipment. By addressing all of these technical and administrative considerations, you can ensure that the installation is safe, reliable, and compliant with all applicable codes and standards. In conclusion, the NEC provides a comprehensive framework for the safe and effective installation of electrical systems, including generators and their associated wiring. While the NEC generally prohibits the mixing of Class 1 and Class 2 circuits, an exception exists for functionally associated equipment. To take advantage of this exception, it's essential to carefully consider the specific functions performed by the Class 2 control wiring and to consult with the local electrical inspector. By following the NEC, the manufacturer's instructions, and other applicable codes, you can ensure that the installation is safe, reliable, and compliant.